Welcome to another Hacker Hermanos video. For this video, we're going to be covering the demo for NAT forwarding using iptables. So just like the previous scenario, we have Mythic running on a C2 server. We have a listener on port 80, which we can see if we go to the listener configuration showing port 80. We also have a profile pointing to the IP address of our C2 redirector 192.168.1.155, which we can see in the top left-hand side of the screen. We still have the same target with the IP address of 192.168.1.192 that has a DNS record of redirector.local pointing to the IP address of the redirector 192.168.1.155. At the moment, we do not have any sort of redirection enabled, and we can see that if we issued a web request from the target, we will see it arriving in Redirector from the packet capture. Let's take a look and do that. We do invoke web request with PowerShell. We can see the traffic arriving on the C2 redirector sourced from the target machine 192.168.192, destined to 192.168.1.155 on port 80. We also have a packet capture on the target that shows the same packets sourced from 192.168.1.192, which is our target, destined to 192.168.1.155, which is our C2 redirector. The packet capture on the C2 server shows that because the C2 redirection is not set up on the C2 server, no packets are forwarded to the C2 server. This will change once we enable C2 redirection using the NAT operation through iptables. Go back to our C2 redirector, we'll clear the packet capture and start it again. But now what we will do is set up C2 redirection using NAT. We'll drop the following commands. If we go line by line, the first set of commands clear any chains that iptables has, which is a collection of rules, and we'll then issue a destination NAT directive to tell C2 redirector that any traffic on destination port 80 is to be forwarded to the IP address of the C2 server 192.168.1.166 on port 80. Additionally, iptables is set to do two more operations, which are masquerade and forward accept. Masquerade is modifying the source IP address of the packets that are going to be sent from the C2 redirector to the C2 server to put the source IP address of the C2 redirector. This is what will ensure that the C2 server will be able to respond to the C2 redirector instead of the target. Additionally, it has an action to accept packets being sent to the C2 redirector, and we're enabling IPv4 packet forwarding, setting it to true with the value of number 1 at the kernel level. This is necessary to have our C2 redirector effectively act as a router. Let's apply this configuration. Next thing we can do is validate that the configuration has been applied successfully. And we can see that if we issued the commands iptables-l as in Lima and iptables-t as in Tango, NAT for network address translation NAT-l to list, we're seeing that any traffic that is destined to port 80 TCP with the protocol HTTP is accepted. Additionally, if we scroll down, we can see that any traffic that is being sent to port 80 is to be applied the operation destination NAT that will change the destination IP address in the IP header to the IP address of the C2 server. We're seeing that here, 192.168.1.166 on port 80. Additionally, we're also seeing that masquerade is to be applied after the packets have been routed to any packets. This masquerade operation, like I was mentioning a bit earlier, is what ensures that C2 server will be able to reply to the C2 redirector. Let's start forwarding some packets now. As a reminder, packet capture on the C2 server, and now we're going to issue a web request from the target to the redirector on the DNS record that will resolve to 192.168.1.155, which, if you look at the top left-hand side, is the IP address of our redirector. This traffic we're expecting to see also arrive at the IP address of the C2 server on the bottom left. As expected, we can see that traffic is being sent from the PowerShell to the C2 redirector. We see that the PowerShell client or invoke web request has a source IP address of 192.168.1.192, and the same packet has a destination IP address of 192.168.1.155 with destination port 80. We're seeing in the user agent field that it has Windows PowerShell as expected, and we're also seeing in the Windows PowerShell window, we're getting a 404 not found. So let's first look at the C2 server and see the same HTTP web request that you can see with source IP address of the redirector which is 155. And we can see that it has a destination of 166, which is the C2 server IP address. It has a destination port of the listener on port 80. And we're seeing the same user agent, which means that these are the packets that we sent from the target on the PowerShell client. If we now look at the C2 server response, we can see the same packets in the C2 server that are sourced from the C2 server 192.168.1.166 with a destination IP address of 192.168.1.155, which is the C2 redirector. We're seeing that the response contains a 404 code not found. And we can see that in the C2 redirector, if we look for that response, we have it right here. This response is sourced from the C2 redirector and is being sent to the target sourced with IP 192.168.1.155 on port 80 and sent to the target on IP address 192.168.1.192. It has the same body of the message with HTTP code 404 not found, and that is the response that our PowerShell client indicates that we received, that 404 not found. Now, let's see what happens if we clear our packet capture and try a C2 implant that we're seeing is destined to the C2 redirector. We're going to look for the mythic callbacks, which at the time we don't have any, but as soon as we run the C2 implant, we see the new callback being registered. Additionally, what we can do is increase the frequency with which the callback occurs, and we will see an increased frequency for the chatter between the two C2 redirector, C2 server. As the first 10 seconds go by, the chatter increases, and now we have interactive exchange of messages. If we were to exit the callback, we'll see that the chatter will stop immediately and the process will have exited. We look for that process, 1056. We will not find it. No process returns with 1056, nor with the name of the payload. In contrast, if we are to run the payload again, we'll see that this process exists and it's running on process ID 10160. We're to terminate it. Same thing occurs. Process is nowhere to be found. That's all we have for today. Thank you.